All right, let's have some fun. Do you feel good? Last talk today, last session? Everybody a bit tired? Maybe?
Just a little.
Relax a bit, it won't be too hard.
So, welcome to our talk. Christian and I will give you a short, or maybe longer, insight in quality assurance in TYPO3. And this should be relaxing for you. It's more storytelling, it's a bit of history, and there won't be a line of code, so don't worry. Okay, so what is this talk about? How do you usually recognize what we're talking about? It's this one, it's this guy. It's our core CI, which hopefully provides you with a verified +1 on your grateful contribution to TYPO3 core. And what's behind this actually is what we are going to talk about, because there's quite a history behind that and also quite some sophistication, I would say. Just for our information, who has ever taken a look behind the scenes there? Just raise your hand, please. Okay, cool. More than I expected. That's good, great. Yes, so let's get started. Who is talking to you? Christian, next to me. I guess most people know him. He's a long-time community core member, actually, and does all the fun stuff. I was working for the core as well for quite some time, but currently I'm more in the background. So why I'm here doing this talk then, actually? Long story short, I was attending a conference about software quality, and I thought to myself, maybe just take the chance, go to the call for papers, and tell them I want to talk about something that is not the usual thing on a commercial conference. I will talk about open source, and I will talk about how we do quality assurance in open source, actually. And the paper got accepted, so the call for paper was accepted, and I parts of this talk were held there already, and I had Christian to my side, and he was the helping hand, giving me lots of information about the current status and so on. And so while we were talking, we actually said, how many people in the TYPO3 community, for example on the developer days, are actually aware of that stuff? Because it happens behind the scenes, it's just a casual -1 or +1, whatever comes along. So we decided, let's give it a chance here as well. Maybe they want to hear about this. And yeah, luckily we are here now. So what we are going to talk about. Why does this stuff matter at all for you and for us? A few facts about quality assurance within our ecosystem. What is tested? How do we test it? What does the infrastructure look like? And of course, the learnings. What could go wrong, or what did go wrong in the past, and what can be done better.
So why are we putting so much time into this area? Why is it important to us? That's the basic key. And a lot of time is being pushed into CI integration and testing and stuff. And yeah, we always have to remember why we're doing that.
Exactly. So what is the general motivation for doing quality assurance? Or what we do here is continuous integration. The key, it's actually the key for open source when it comes to quality, because if nothing is automated, if no testing is done properly, and without involving humans doing it all the time, your open source project simply won't get to a questionable quality state. So if you compare the setting we're in an open source project compared to a typical commercial entity, you can identify quite some differences. For instance, if I mess up with the CI in my company, my boss can simply fire me. So there's some form of power which is above me, which limits my, let's call it, bad intents. In an open source world, or at least how we handled it at TYPO3, everybody can do anything. And we will see later on what this means and what the implications of this are. And of course, quality assurance and writing tests and using testing methods is always a learning thing. So you always learn things about your own code and so on. So some technical facts.
Yeah, technical stuff. So we're dealing with a not too young project here, right? We have subversion in Git, later Git, first subversion is since 2003. And I personally find myself quite often dealing with the version history and looking up stuff. And it does happen that I stumble upon Casper's initial commit for stuff, and that is from 2003. And that's awesome because we have such a clean history and can look up stuff to answer questions like, why is it like it is now? Yeah? So version control is very important for us, and we have it for quite some time already, more than 20 years.
Some numbers. Yeah, let's crunch some numbers because I wasn't aware either how large is the project currently actually, at least in terms of PHP code. You can read the numbers on the slides, but we crossed 500,000 lines of code. Remember, we threw away quite a lot of hundreds of thousands of lines of code already in the past because of advancements in technology and so on. So lines of code-wise, we hopefully get smaller by the time while maintaining the same feature set. But as you can see, the classes and also the number of methods is actually quite a lot. So you can compare it with the numbers afterwards regarding how many tests we have in which area. And that's not all. We have a bit more.
Yeah, we're dealing with a not too small project in the first place here. The core monorepo is like that. But we also have quite a few additional libraries at hand. For instance, Fluid Standalone, which we are taking care of and maintaining. A couple of further things like the HTML sanitizer and further libraries. So that's not everything. And we have our dependencies, and those are like some 100,000 lines of code as well. And that is basically our code because we integrate it into our system. And we own that code when you look at that from a framework perspective, because we use it and we need to take care that everything works well together. So that's not the only stuff of the code base. We are currently in the process of adding PHP 8.4 because Alpha 2 is now ready to the system and make it compatible. And that means we are also dealing with our libraries directly. And now we know, again, which of our libraries, of our dependencies, do work and which don't, and which are well maintained. And that's very important for us. That's why we look at dependencies so closely and have a hard fight if or not we want to integrate them and all. Exactly, and as the slides already say, JavaScript is not, we didn't even mention JavaScript, so all our front-end or back-end user interface stuff is covered with tests as well. So yeah, more code to check. So let's take a quick look. What are the aspects of our CI actually, maybe which is not default for any CI, but what we do for specifics. We cover a lot of different platforms. You know, all these kinds of database systems, various operating systems which have different PHP versions and so on. TYPO3 is open to all of that. So we have to somehow ensure the quality and that things work there. If you think about certain commercial software, which is only tested on, let's say, Windows, your testing environment, or at least the possibility to test things, are quite a lot smaller. Of course, like some huge corporations, we also have developers spread over the whole world, but we do not require contracts. So as I told before, there's no higher power, some legal stuff or whatsoever, which somehow rules how people will interact with our code or what is contributed in which style. We have guidelines, but if somebody violates them, the system has to be safe enough, secure enough to make sure that things don't go nuts. Yeah, the core team, who is responsible? Yeah, so we are faced with the situation that we have quite a huge code base that is used in all sorts of different environments. And we not only have to do releases in time, but they should be stable as well, and they must not break. And we don't know how exactly certain stuff in our code base is actually used on which platform, and we have a lot of permutations in this area. And all that needs to be tackled somehow, and that isn't possible if we don't have a good CI that tells us if something breaks. If a library does something that breaks us, for instance, we need to know now. That's very important.
So tooling-wise, we are based on Gerrit for the reviewing system, and GitLab is the one running the pipelines for doing the actual testing. And so the challenge is maintain stability, enhance code quality over time, despite having a rather small core team, and close to no rules when it comes to contributing stuff. So a few facts about what quality assurance looks like in our ecosystem. We had our first unit tests, at least according to our version control, back in 2009.
Who knows, who could guess who contributed the first unit test to TYPO3? Some guess. If nobody knows, I will talk to Mark and tell him that he should do that in the to the certification questions. Nobody? It was actually Dimitri, the real URL guy, Dulepov, who contributed the first unit test in 2009. Yay! And somehow this kick-started quite a rabbit hole. So nowadays we end up with 11,600 unit tests, which is quite impressive, I think.
Yeah, besides that, Christian already told us we test not only one PHP version, but currently up to 6, and of course a permutation with 4 database systems, and the number is maybe even growing. And yeah, Christian asked GitLab, what was your work in the last 3 years roughly? And they said, yeah, we ran around 60,000 pipelines with over 3.5 million jobs. So think about your products or your projects in your companies. How many projects do you need to do to come up with such numbers? I mean, yeah, you can run useless jobs with just an echo, but these are useful jobs here actually. So that's really quite a work that had been done.
Early and often.
Early and often, yes. So that brings us to the strategy, early and often. The main goal for our CI is not to run at some arbitrary time and at some point telling you that the code is now broken. But the idea is also to enable new contributors to get a quick feedback on their code, to provide feedback within Gerrit as fast as possible. It doesn't help anybody if it takes 2 days to receive some CI feedback that you missed one semicolon somewhere. That should be faster. And we believe it does a quite good job currently because we're running it in less than 6 minutes. And what's run or what the amount of stuff that is run, we'll see a little bit later. But yeah, so 5 minutes is actually quite okay.
And that's not just one run, right? So we're doing like 2 or 3 database systems by default whenever you push something. And the unit tests in various permutations and with various PHP versions as well. So we are running like, I don't know, 60, 70,000 tests in like 5 minutes. That's quite impressive actually.
And it happens whenever you just change a typo in the commit message. So
no exceptions, just everything, go ahead.
Yeah, right. What is also very important is how do you test your CI environment actually. So it's really important that everything is reproducible locally on your machine. So it has been a really striving goal for the team to build an infrastructure which is not only running on the official CI servers, but also locally on your machine. Of course, it will take probably longer than the 6 minutes, but at least you get a quick impression what is going wrong if the CI runs on Gerrit are not, or on GitLab are not telling you enough, or if you want to test CI itself, for instance. So this is actually achieved. So we have this exactly same stuff going on locally as goes on the CI. Of course, except the permutations of the database systems.
That's crucially important to us. When the CI tells you something is not good, and you take the command and put it into your shell, then the exact same environment is kick-started and run, and you will get the exact same error and can debug it locally with one click. That's really easy, and that's very important to us. Otherwise, it's just like guesswork locally. That won't work.
So, and the third major goal in the strategy is how do we ensure that upgrading libraries like PHP itself actually doesn't throw us away with deprecation or breaking stuff. So the test coverage and the setup has to be made in a way that whenever we add, for example, a new PHP version like 8.4,
which we are currently doing,
that we can see upfront that something will go bad once this version is going to be released. So whenever we kickstart 8.4 now in the CI system, I'm sure there will be one or two places in the core which found some new stuff.
Yeah, the fun stuff is we fixed all that already, and there's just a single library that didn't release and fix their own bugs yet, because it's now our code. It's that library that we own now because we use it, and they didn't fix it yet. So that's like, I don't know, we will give them a week. Yeah, it's Firebase JVT at that point. Somebody from Google here? No, fix it for us, please. We have a pull request, just merge it and release it. So this is currently blocking us from enabling the PHP 8.4 unit tests in TYPO3 because one library didn't yet catch up.
Yeah. So let's take a bit deeper look what is actually tested and when do we test something. What we were talking about just currently, when you submitting a patch to Gerrit, we actually run for each patch version the full testing, and it's done, of course, before we merge any stuff. So everything you push to Gerrit is actually converted to a dedicated branch on GitLab, which is then run through the pipeline. But once a day, the so-called nightly tests are run, and those are even more and longer. And you know how long it takes currently?
I don't know, half an hour maybe, something.
So at least 3 to 4 times longer.
So more permutations, more edge cases, older library versions, maximum version of libraries, different database versions, all that stuff. That's what we are mixing into the nightlies to be very sure that our current state is green.
For instance, as an example, the unit tests might be run in a certain order for the regular patches, but during the night lines, these are simply permutated in the order how they are executed, so you can even rule out some inter-test dependencies which might also cause issues, which we had in the past.
They are the devil, yeah? If you have a unit test that is green and fails, if the unit tests are in a different order, you know you have a cross-dependency between unit tests, and that's a plague. This must not exist, yeah? So we just do that with a random order, and sometimes then they tell us, you still have a cross-dependency somewhere.
It can happen, actually, yeah.
It happens.
So, what does it mean if a nightly test goes red? Because obviously, we fixed the last commits went green, otherwise these wouldn't have been merged. So, how does it come that a nightly goes red? Exactly because of these permutations, and specifically the min and max versions of dependencies. And these are of utmost importance to be fixed, because whenever you don't care about these reds, your entire quality assurance from that point on is more or less useless. So this is why maybe you saw it on Slack during the developer days. The test went red yesterday or 2 days ago, I can't remember even. And Anja was immediately stepping in and saying, oh, there's a problem. And it was exactly a minimum maximum test, because PHP Stan as a dependency had a bug in the newest version. That's how it is. So we had to conflict this version and avoid the PHP Stan bug. Yeah, then it went green again.
This happens, yeah, not just very seldomly, but it happens. Like this time, PHP Stan had a bug fix release. We used it in our max test, it got red, so they released in the afternoon, our nightly said it's red, in the morning we got it fixed again. In this case, it was actually PHP Stan's fault, and I think we now set a conflict for this version, but it also happens that we actually find bugs in new releases of our dependencies, like in Symfony a couple of times already and others.
Yeah, exactly.
So they get an issue for that the next day, which is quite amazing.
Yeah. And sometimes the fix together with the issue.
Maybe with a pull request, say, look, merge it and please do another release.
Okay, so you're going to push a new change to Gerrit. What we are looking into, actually, what is tested when you're pushing stuff? We have these kinds of tests. We have these unit tests, those functional or integration tests, depending in which environment you are in industry, people are calling it differently. And we have those end-to-end tests, obviously, which like click in the browser and doing a backend login, clicking menus and so on. So this, if you take the perspective of levels, the unit tests are the simplest ones and the fastest ones. The functional or integration tests actually use a real database. So the data is read from the database and stored and compared. And the end-to-end test actually fires up a headless browser and does all the clicking in the browser.
So look, we are doing 7,500 something functional tests. A functional test means we create a TYPO3 instance, we create a database, we create the database schema, we have a completely standalone functional test, and then we run the test on that instance. So that basically means we are creating 7,500 TYPO3 installations in 5 minutes.
In addition to the end-to-end tests, because those create a new instance as well, as far as I know.
Of course.
So it's even more, yeah. Then we employ quite a lot of tools doing some kind of static code scanning or analysis, so telling you that you probably screwed up at some point because you overlooked some boundary, some data type, some whatever. That's PHP Stan, for example, one of these libraries helping us doing this. And tons of integrity checks. Did you write the correct commit message? Are your code annotations correct? Is the exception code you just introduced actually unique? Did you, for some reason, introduce a Git submodule, which we don't like? Or any CGL violation, or you name it. The list is way longer than we could put on the slides. And those evolved over time.
And we continue adding stuff. Yeah? For instance, we do want that our tests are declared final. So we have a checker that finds all our tests and looks if they are final, and if not, CI goes red. Because we do not want that somebody extends them, stuff like that.
So, quite a bit of history as we talked. So we had the first unit test in 2009. It was executed manually back then. And
do you
locally.
know how? Does anybody still remember how we actually executed tests back then in 2009? Yeah, we had a backend extension and you could click on it and say run test. That was awesome. They're really funny. Yeah.
Consider clicking this 10,000 times. Every time before you push a commit.
Yeah, it was a plague because it was run within the context of the backend, which meant that it inherited all the state that the backend comes up with, and in this environment you had to run the tests, and that was not a too good idea, so we got rid of it.
Yeah. So automation kicked in only roughly a year later, and Jenkins was employed.
Actually Hudson, right?
Yeah, right, it was Hudson, yeah. And so it was responsible for running the tests on our own infrastructure. Then, a few years later, Travis came on the market, cloud-based host testing provider, let's call it this way. Who remembers the infamous Travis incident? Oh, a few people were there. There's a fun story back then. We had a code sprint with quite a few active people, and we were pushing patches. More patches and more patches. And they all were pushed to Travis, because Travis was running the tests for each patch version. And we actually pushed so many patch sets that the queue management of Travis got broken, and finally the whole Travis system was down. So we more or less did a denial of service attack by doing normal work. And this led to funny phone calls, and TYPO3 even offered them money, how we help you, we give you the money, get the stuff right. But it actually didn't work out, they didn't like it, or I don't know the exact story, but the fun thing was Travis worked really well for quite a while until we had this famous code sprint.
Yeah, so that's like an achievement earned, yeah, because we successfully killed the cloud scale infrastructure. And they came to us and called us, what the heck are you doing there? We're dead right now.
Yeah. So this led to some changes in the infrastructure again. And we got some Bamboo instances, and we got some servers in a data center from Leibniz. They donated actually the CPU hours and all that stuff. So this was really nice. And we had our own infrastructure based on Bamboo running there for quite some time. And a few years ago, like 4 or 5 years, GitLab took over from the old infrastructure. And that's also what we still have today, basically. But how GitLab runs the test did change quite a bit as well. Back then, we started off with having Docker in Docker. So basically, we had a Docker container running on the GitLab runner, which then executed the test within another Docker image. Should be safe enough, someone would think. We'll see, we'll learn better in a minute.
So the current structure is basically that git.typo3.org, which is provided by the server team. So the GitLab instance is by the server team. That's what we are using. And the only thing the core team actually takes care of is the runners which execute the test. And those are managed by the core team.
So in order to improve security actually, and also some other stuff, Podman got introduced only last year. And currently, the operating system used within the runners and the containers is Ubuntu. And Podman, Christian is currently looking into upgrading Podman into the latest version, also to mitigate some stuff which is going on currently. But the overall experience, and we'll see a little bit later, is much better with Podman now actually in comparison to Docker and Docker. And from my personal experience also for live hosting stuff, when you do not use other container technology, Podman is something you might want to take a look into.
Yeah, so Podman is a drop-in replacement of Docker. It does everything that Docker does, but better, basically. So it's more fun. I came to hate Docker quite much because there's nasty stuff in there. Yeah.
So how does the process currently look like? You're doing starting a review on Gerrit. By the way, we have linear history. That's also something that people often overlook, that this is something really crucial when the size of a project is growing large. Because if you have all this branching stuff going on, looking back 20 years of history can be quite daunting if you have all this intermediate commits somewhere. I mean, there's tools and it's getting better, but this linear history stuff is actually something that we did right, in my opinion, and it can't be wrong if Gerrit is actually offering this option, and as far as I know, even Google is using this method of keeping a history in their products.
So who of you did not yet find an answer in the commit log or in a commit message within the TYPO3 repository when you looked for stuff? Who did not got an answer from the commit message?
I always got the wrong answer. It always told me that I did fuck up in the past. So yeah, so whenever you push there, a new branch is created on GitLab, as I told before, and this triggers the CI pipeline, and the result is then commented and voted back to Gerrit. That's the famous +1 or -1 we saw on the first slide, which tells you, yeah, you're doing good. If you want to know the details, the link is there as well, so just click there, take a look how these jobs are structured, what is done when, and what are the dependencies, because our current setup is this stuff is public. We'll see a bit later what this implies, but this current setup is actually, we split the load over multiple runners. So of course there's not only one runner doing all the tests, but a bit more. All the container images are maintained by the core team. So Stefan is one of the names to mention here. So those images are really handcrafted and strive for highest quality and yeah, fitting our needs.
So a huge thanks to Stefan at this point, because he's doing a very great... He's really doing a great job. When PHP Alpha 1, PHP 8.4 Alpha 1 came out, we had our PHP image ready 2 days later, and 3 days later? 12 hours later. And started working on it. Yeah, that's quite incredible.
Yeah, and keep in mind it's not only creating a simple image somehow, because all of you are running different operating systems, calling ARM x86 and so on. So all those images are available in all these variants. So you can use them locally, whatever you're using for your local development. So keep that in mind.
The thing is, if you have that Apple system under your fingers and you want to run the test on your Mac, then you are probably using ARM architecture. And that means to be on speed, we need to have compiled images for ARM as well, and not only for AMD 64. And that's what we're doing as well.
Yeah. So each patch that you're pushing to Garrett triggers then these roughly 60 jobs. Those are like run unit tests, functional tests, and all the stuff we were talking about before. And if you really keep pushing towards Garrett, the current hardware manages to run roughly 250 jobs in less than 10 minutes. So if you do the math, you get a response in under 6 minutes. Somebody else is doing the same. You can roughly have an idea what is going on. So the big question that might come up is, what hardware is actually in use?
The point at that time is, this is important for us to be relatively quick, because when we look at security releases, for instance, security stuff is done under the hood by the security team, and they prepare the patches. And when there is a release day, then we commit those patches. And at that point, the issue is open to everyone, and everyone starts looking at how to, I don't know, break it. And that means as soon as we merge those patches, we have to get a release out of the door quite quickly. And when we have security stuff, they are quite often backported to many branches, and they are usually a couple of patches. So we end up with like 18, 20, 24 pipeline runs like that. And we have to have an answer if everything's still green before we do the tagging. And that means that process must be a quick one. That's why we need good throughput.
So, best is you tell us about the hardware.
Hardware, Hetzner, everybody probably knows Hetzner. Good hardware, cheap. We are currently using 4 Hetzner 16 hardware core systems, 128 gigabytes of RAM. We are running on one machine 20 jobs in parallel to keep that hardware busy. 22 jobs in parallel. This changes a bit sometimes. The GitLab server itself is relatively small. It's just a standard virtual host managed by the server team with a couple of gigabytes of RAM. For the communication between our review system and the CI, we have a couple of very small intermediate virtual hosts within the Hetzner cloud that takes like, I don't know, less than €5 a month or something like that. For the communication and the splitting stuff, when you merge a patch, then monorepo is split into smaller packages, which then goes to packages, and this stuff is also done in this infrastructure with another tiny virtual host. So that's the basic setup. We have the GitLab server, we have 4 Hetzner hardware machines for the runners, and some small communication stuff.
So if we think about what we have been talking about all the time, we have this open infrastructure, and the mantra in TYPO3 is inspire people to share. We are sharing also the service definition of how our CI works publicly. So compare that to a commercial entity. If you ask them, please publish your entire CI setup, I want to learn something from it, I expect not to get an answer at all, actually. So what we do is we do the opposite. We give out this information. How does a CI infrastructure need to look like in order to achieve what we are seeing here? Maybe that's helpful for you in the company as well, to see at what scale, what hardware do I need for our purpose. I mean, for example, it could be a small project and some virtual host with 2 CPUs is enough for a runner that runs only once in a week. You can choose, but you have an idea of what it looks like when you run this amount of jobs and this kind of tests. So you get an idea. That's the point. But this has security implications, because if you know how the infrastructure looks like, you open up a new door for motivated people. And motivation could mean you break out of Docker. Back then when we had Docker, there was this thing that if you push the right stuff and you know what to do, you could actually break out of your Docker container. And there was some solution, there's the sysbox thing. Christian can tell us a bit more about it.
Yeah, it gets some things right that Docker fucked up in the first place and encapsulated stuff better, because Docker is basically usually run as root, and that's not a good idea. And this is, by the way, one of the things that Portman got right.
Yeah. So
that was one of the motivations to actually start with Portman, because that Docker run as root is like not a good idea.
So if you're interested into this detail, Google Sysbox. There's an entire blog entry on the web explaining all what's all going on there in the kernel stuff and so on. It's actually really interesting if somebody is into this. But switch over to Podman and you don't need this blog anymore. So what did we learn? There's a saying by Christian: tests die by themselves. What does it mean?
That's a fact. Yeah. If you don't run a test often, it will die. If you write it once, execute it once, and then leave it alone and run it in 3 months again, it will be broken. Yeah, be sure about that. If you do testing stuff, then do it often and early. Yeah, if you can't do that, then don't bother.
Yeah. So another thing we learned is, for some reason, Docker is not always stable. The servers, the runners actually died after a few weeks, or roughly around 12 weeks. I mean, keep in mind there were no reboots in between, but for some reason they died. Christian and the team decided simply to re-establish the whole infrastructure instead of trying to